Hi, hello and welcome to Learner's Coach. So today we are going to look at normalization of database tables, right? Now this is a very important process in developing our database, right? Or even designing so that we ensure that we eradicate redundant data within our database. So we are going to look at the various categories or stages of normalization. Yeah, the first normalization, second normalization, and third and fourth, right? Now, normalization is actually the process of assigning attributes to entities. Yeah, it helps us reduce data redundancy and help also eliminate and eradicate data anomalies. We're going to look at the various anomalies like update anomalies, delete anomalies, and so on. So take note that the highest level of normalization is always not recommended, right? Because it comes with its own cons in that we'll have a lot of redundant data. So there's a universe of discourse here, looking at a particular construction company. We are going to use this kind of case study to help us understand how we can normalize a particular existing scenario. So we are going to look at a construction company that has a project employees, right? And maybe say the two entities, how we can maybe normalize them so that at least we eradicate these kind of anomalies and redundant data that you have talked about. So there's a kind of relationship between employee and the project. Yeah, you can see employees are assigned, yeah, to some particular project, right? So this particular table is what this diagram shows the already pulled out report, and you can see we can identify various problems that emanates or comes along with it. Like if you look at the project name, right? The project name, you can see there's some kind of blank areas like project number 22. Yeah, we can't really establish the project name, right? So that's one problem that you can always use normalization to eradicate. When you also take a look at, for instance, when you look at the job class, there's some kind of repeated data. Yeah. So these are some of the things that we need to eradicate using normalization. And the actual structure of the table that made us have that particular report is this one. Yeah. So better still, you can see how it was implemented. Yeah. So we have the project number, project name, right, and the same story. There's some kind of repeated or redundant information that you can observe, and this is what we need to really eradicate using normalization. So the previous table or the previous figure is what we need to understand. Yeah, that the project number is intended to be the primary key, but it has null values as we have seen, right? The table, as you have seen, also displays that redundant data. Yeah, the entries within the table is also inconsistent, and maybe the worst case scenario is that we are going to be faced with these anomalies, such as the update, addition, and deletion anomalies. So this one actually presents a way or a situation whereby normalization will have to be done in order to have well structured database. So how do we then proceed to ensure that we have normalization? So let's look at the first normal form. Now this particular diagram just shows how we can always engage the first normal form. So a first normal form, yeah, is a table that doesn't have repeated groups, yeah, or repeated group of data. Yeah, so repeating groups can be eliminated by adding the appropriate entry in at least the primary columns. So when we want to start the normalization form, we need to actually implement it within the first normal. So this one, within the first normal form, kindly take note, every table or relational table must not contain any repeating group of data, right? Again, repeating groups can be eliminated by adding the appropriate entry in at least the primary key. So we must have a primary key. That's the guiding principle of the first normal form, so that we eradicate the repeating groups. Fantastic. So you can see, yeah, the data is here organized in first normal form by the fact that every entry has what? A unique identifier or the primary key, and that is the project number, as you can see, right? So don't bother about the repeat. These are the added or repeated values, because you're going to eradicate them, yeah. But the concept here is that it has some kind of unique identifier. Now, for us to maybe eradicate the problems that comes within the first normal form, we need to look at the dependency. Yeah, dependency will actually help us eradicate those repetitive information. Yeah, so we are going to look at or use the dependency diagram. Yeah, like right now, this particular dependency, we have the partial dependency and also the transitive dependency. Yeah, like the partial dependencies, as you can see, yeah, they are linked with some kind of arrows, and also we have the transitive dependency and also the partial dependency. Now, all these dependencies, we are going to look at how or which one is the best and which one we can always eradicate. Yeah. So take note of this first normalization diagram, dependency diagram, because you can see the primary keys are in bold and underlined. Yeah. The arrows above entities indicates all desirable. Yeah. So these ones are must have. Yeah. The arrows that are actually be above these particular entities. Yeah. Like for example, we have the project number, right? Yeah. And the arrows below the dependency diagram indicate less desirable, like the partial dependency and transitive and partial, the transitive dependency. We can always eradicate them, yeah, or transform them in a manner that can, they can help us remove the repetitive data. So from that understanding, we now can be able to establish that within the first normal form, all the key attributes should be defined, yeah. There are no repeating groups in the table, and also all attributes are dependent on the primary key. Yeah, so I think that's we had already looked at. So converting the first normal form to second normal form, yeah, we need to ensure that at least we break, yeah, those particular dependencies. So you can see there's an introduction of a new attribute or a new actually entity, right? You can see the assign, yeah. So we need to write each key component on a separate line and then write the original key on the last line, as you can see. So we have the project number and the employee number, yeah, that actually help us break down the kind of dependency that we realized within the first normal form. So that's the first way that you can always break or convert the first normal form to second. So the diagram here shows how the step has been executed from the first normal form. Now looking at the dependency, so you can see the project number must be linked to a project name, yeah, and also we have the transitive dependency, like the job class and the hours that is being charged, or the charges that are being executed per hour, yeah. So these are the two transitive dependencies that have been eliminated, the job class. So breaking that down further, we can say we have now the employee being associated with a particular, is being associated with the hours that they have done, and also the project is being associated with the number of hours that maybe that particular project was executed. So you can see how the dependency are now being, at the last final step, how they have been broken down. And this calls for another entity, and that's what we looked at as the assign entity. So in a nutshell, the second normal form can only be established, yeah, if it includes no partial dependency, that is, no attribute is dependent on only a portion of the primary key, right? That is a very, very important. part to ensure that we understand when it comes to the second normal form, right? And you can still go ahead and convert the second normal form into third normal form, right? So at this particular juncture, we need to create a separate table with attributes in a transitive functional dependency relationship. Yeah, as you can see now, we have now the four entities. Now we have the project. Yeah, we have the assigned attribute. I mean the entity. We have the employee entity, and also we have the job entity. As you can see, the job entity now has the job class and the charging hour, or the charges made per hour. Yeah. So these are the four entities that can be established within the third normal form. Let's see what is required on this particular third normal form. It is a table is in the third normal form if it is in the second normal form and it contains no transitive dependency, right? It contains no transitive dependency. So there's a diagram here showing the third normal form, how the various entities have been structured, though not very clear, right? Now, there is some kind of related concept when you talk about the third normal form and the Boyce code normal form, yeah, referred to as the B, C, and F. Yeah. So a table is in Boyce code normal form if every determinant in the table is a candidate key. The concept here is that should we have a particular entity that has some attributes, and those particular attributes can be broken down so that they stand as the key attributes or the key or the unique values on their own, that one we say that we can have a Boyce code normal form. Yeah. So a determinant is any attribute whose value determines other values within a row. Like you're going to see how to maybe relate the third normal form and the Boyce code normal form. They are almost similar, but the Boyce gives a scenario where that every available or every determinant in the table has the capability of becoming a candidate key. So we can't talk about the Boyce with CNF without really understanding how the third normal form has been structured. So this particular table help us understand. As you can see, we have this kind of transitive attributes or dependency that you can always eradicate. Yeah. So it has been decomposed, yeah, to meet the B, C, N, F, right, requirements. Yeah. As you can see, the first diagram shows the third normal form, but actually it's not a what? Boyce normal form that we really want. Yeah. So second normal form allows us to understand how we came up with the third normal form. But again, the last and the final diagram tries to ensure that, for example, entity C, yeah, is associated with the entity what? A, right, within the third normal form, right? So we can always separate, yeah, this particular engagement between A and C at some level, right, so that they all stand alone as shown. Yeah. So the sample data here shows how this particular third normal form has been converted to the B, C, and F, right? So that's again, I think now this diagram shows how we can implement, yeah, the B, C, and F. As you can see, every almost, if there's a particular attribute that can be converted to be a candidate key, can always be associated at the B, C, and F level. So that is well cut out. You can see now we have the class code, the student ID, yeah, and also we have the staff ID, right? These are all capable candidate keys. Yeah. So normally you will not be maybe expected to have this kind of arrangement, but should the situation force, it's always good to decompose into B, C, and F, right? So they're almost similar with, to the third normal form, but this option gives us a scenario of ensuring that any determinant within a particular table should be given a priority of becoming a candidate key. So at this level of B, A, C, and F, we say a table is in B, C, and F, yeah, or Boy's code, a normal form, if every determinant in that table is a candidate key. So if a table contains only one candidate key, right, that normal and B, C, and F are equivalent. Yeah, so they are almost related. But if you have several candidate keys, we now talk about that as a B, C, and F, right? Now, we can now look at the design aspect. Now that we have done those kind of normalization, of course, we have other normalization forms that you're going to look at, right? So database design and normalization example based on the universe of discourse that we looked at, the construction company, yeah. So we can summarize the operations as follows. The company manages many projects, right? So each project requires the services of many employees. Sorry. An employee must be assigned to several different projects. So this enable us to, this kind of scenario enable us to understand how relationship is actually implemented in the different entities, the kind of attributes that you expect from each and every entity. Now this one also is going to help us understand the anomalies that we can engage with in the future, like the update anomalies, the delete anomalies. Yeah, a good example is that maybe we expect a scenario whereby if we delete an employee, for instance, right, an employee information, it should not actually delete the projects that they were working on. Yeah, so we should prevent this kind of anomalies using normalization. Yeah, so here is how we have implemented. Here is how we can implement now the new entity. Yeah, based on after the normalization, as you can see. So there's many to many relationship here. So some employees are not assigned to a project, and project is optional to employee. So this is a kind of relationship. Yeah, you can see optional and must. Now, three entities after transitive dependency are removed. Yeah, so after transitive dependency is removed, we can have the three entities, as you can see, the job entity, the employee entity, and also the project entity. Yeah, so that's the first step. And here is how the newly modified ERD for the contracting company now looks. Yeah, so you can say every employee requires a job, and there's an employee is assigned to a particular project, right? So at least one employee is assigned to a project, as you can see, and also there's some kind of some employees are not assigned to a project. That project is optional to employees. So this is after normalization. We can have this kind of the three entities being implemented. Again, we can look at the finally implemented ERD, right, after the normalization. As you can see now, the employee is associated or manages some kind of project. Some employees are assigned projects. Employees can also, they require some kind of job. So based on the normalization that we have done, we can now ensure that we have a well normalized or structured database that is going to help us eradicate anomalies such as update, delete, right, and of course remove redundancies, right. So just to understand what happened behind the scene during the normalization, yeah, like we had the assign our attribute is assigned to the composite entity assign. So we have a particular new attribute and a new entity, as you can see. We also have the managers concept, yeah, this relationship that is created between the employee and the what? And the project. As you can see how the various entities have been broken down and associated with the different attributes. And better still, the relationship between the project and the employee, and of course the job and the employee, and of course the assign between the employee and the project, right? So you can see the power of normalization. It brings a very clear picture of how these kind of entities are implemented with their respective what? Attributes, right? So there's a conceptual framework here, a relational schema that shows how this particular contracting company is implemented. Yeah, so you can see the project, how it's related to the assign, and also the employee and the job. So the relational schema is actually the overall view of how we can be able to determine how the database is going to be implemented. We also have the fourth normal form. I don't know, rarely are we going to maybe encounter it, but it's good to understand what it's all about. Yeah. So we say a table is in a fourth normal form if it's in a third normal form, and has no multiple sets of multi-valued dependencies. Yeah. Now, if you happen to have a fourth normal form, you can always ensure that you eradicate the multiple sets, yeah, so that we don't have these multi-valued dependencies. Yeah? So, for example, you can say we have version 1, version 2, and version 3, right? Yeah, and then we can also see how this kind of set of tables in fourth normal form has been broken and established. Yeah. All right. Lastly, of course, we have fifth normal form, but we're not going to look at it. The concepts where maybe you need to ensure that you decompose or you remove the normalization, we can always refer to that as denormalization. Yeah. So normalization is only one of many database design goals. Yeah. So we need to understand that also normalization or denormalization for that matter can always happen. Yeah. But in rare cases, right? So I think I'll stop there, and we can always maybe ask questions within the comment if you didn't get any concept clear. All right. Thanks.